was a lot of stuff. We're going to do one more. It'll go faster. But questions on anything up to this point? Okay, one more, and we're going to do it not quite so slow. We'll skip some steps along the way. Not a ton of steps, but a couple. Where's my next example? Oh, we forgot to check something. We forgot to check that our x1 and x2 were linearly independent, right? So we should be checking that also. I won't do it because I'm running a little short on time and I want to get through a whole nother example, but it would be good for you to check that x1 and x2 are linearly independent by using the Wronskian. Okay, one more. Here's my next example. I'll write it in a matrix form right away. Vector x is equal to -3, 4, 6, -5, vector x prime, -3, 4, 6, -5 times vector x. Okay, jumping in. Determinant of lambda I minus a. Here's where I'm going to skip my first step. This is going to be the determinant of lambda 0, 0, lambda minus -3, 4, 6, -5, right? Determinant of lambda I minus a. This is the determinant of lambda plus 3, -4, -6, lambda plus 5. If you want to jump right to the second line, you totally can. Just be very careful with your negatives. Ends up equaling lambda plus 3 times lambda plus 5 minus 24. Lambda plus 3 times lambda plus 5 minus 24. I am going to trust that you can multiply and then FOIL this again. So this ends up being lambda plus 9 times lambda minus 1. I'm going to trust that you can multiply out and then refoil when you combine. So therefore, lambda 1 equals -9 and lambda 2 equals 1. So we've got our two eigenvalues. They are distinct. That is good. They are real. That is good. We will do complex ones on Friday, but they are real and distinct for right now. So got to find eigenvectors. Here we go. First of all, lambda 1 equals -9. Here's my matrix that I am using, this matrix right here. I'm plugging in -9. I'm also going to stop writing the zeros on the right-hand side because those are always going to stay 0. If you're doing an augmented matrix and you have zeros on the right-hand side, there is no point writing them. We can just use the coefficient matrix. So -6, -4, -6, -4. No zeros because they're just going to stay on the right-hand side. They're kind of hidden. -6, -4, -6, -4. Remember, I'm plugging in lambda 1 equals -9 into my determinant matrix here. Plugging in lambda 1 equals -9 to my determinant matrix. I got to zero out this -6 right here. So negative row 1 plus row 2 gets sent to row 2. Negative row 1 plus row 2 gets sent to row 2. So I end up with -6, -4, 0, 0. That gives me -6v1 minus 4v2 equals, remember the 0 is implied on the right-hand side. So -6v1 minus 4v2 equals 0. I can pick anything I want. Let's go with choose v1 equals 4. And then v2 needs to equal -6. You could pick 2 and 3, however you want to do it, doesn't make a difference. We'll choose v1 equals 4 and v2 equals 6. I'm going to jump to my x1. So x1 in this case is 4 -6 times e to the -9t. 4 -6 times e to the -9t. Are we good? I'm starting to skip steps. People who haven't had linear algebra, are we okay with me skipping steps? Getting people nodding at me. Good. All right, that makes this process a little bit less painstaking. Okay, Lambda 2 equals 1. Here's what I need. 4, -4, -6, 6. Again, we're plugging lambda 2 into this matrix over here. I am going to need to do what? 3/2 times row 1 plus row 2 gets sent to row 2 to zero stuff out. And so I'm going to get 4, -4, 0, 0. 4, -4, 0, 0. This turns into 4v1 minus 4v2 equals 0. 4v1 minus 4v2 equals 0. So let's go ahead and choose v1 equals 1, and then v2 also equals 1. If we were doing this in class, I would let you guys choose. Not so much today, sorry. All right, so therefore, x2 equals 1, 1 times e to the 1t. 1, 1 times e to the 1t. I'm going to jump and give you my answer in terms of functions x1 of t and x2 of t. So here's my jump. First one, 4c1 e to the -9t plus c2 e to the t. Think about where that's coming from. First row of each of these, first x1 vector is multiplied by c1, x2 vector is multiplied by c2. So then my second function is going to be -6 c1 e to the -9t plus c2 e to the t. And there is my solution to my system of differential equations. If I wanted a particular solution, I would need to give you initial conditions, and then we would solve those the way we did yesterday with matrix operations. Okay, that was a lot of me talking at you for 45 minutes. If we did this in class, it would be way more interactive, promise. Sorry, here it is just a lot of me talking at you. Help me out. How are we doing? Give me thumbs up, especially people who haven't had linear algebra. Yes, we're doing okay? All right, the things we need to talk about. So remember that when we did this with chapter 2 stuff in the characteristic equation, we had distinct real roots, we had repeated real roots, and we had complex roots. Yes, those were the 3 different cases that we had. We have the same thing here. So far, all we've seen, and I didn't make a big point of this, but all we've seen are distinct real roots. That's what we've seen so far. We're actually going to take these out of order. Tomorrow, Friday, we are going to talk about what happens if we have complex roots. That's tomorrow. What if we get complex values for the lambdas? And then Monday and Tuesday next week, we're going to look at repeated. Monday and Tuesday next week, we're going to look at repeated real roots. What happens if we have roots that are repeated? So that's where we're going. It's kind of following the same process as what we did in chapter 2. It's just more complicated with eigenvalues and eigenvectors. Interestingly, it's still called the characteristic equation. People who had linear algebra, you should remember that, right? Characteristic equation, characteristic polynomial. It's still called the same thing. It's just bigger. Okay, take a breath. I am taking a breath. Questions? Anything at this point? Good? Okay. Tomorrow, Friday, oh my goodness, Friday, we are doing stuff with complex numbers. You will love it. It is going to be spectacularly fun. I will send out homework on this. Please, please, please play with it. And this is partially why I have you in homework groups this semester. Double check your work. It's super easy to screw up somewhere along the way, especially because your answers might not match the answers in the back of the book. So homework groups should be used to double check your work, please and thank you. That would be helpful. Last call, anything else? Daniel.
Sorry, could you quickly just explain like why this works?
No.
Again, with the eigen, like y is a e to the eigenvalue t.
Yep, because we guessed and determined that, yes, in fact, that works out. That's it.
Oh,
That's all you
okay.
get. Because we made that guess, and then we said, okay, what equations do we have to satisfy in order to actually have that guess work?
Okay.
That's
Just
it. That's all you get, though.
that makes
Sorry.
Yeah, thanks. Okay.
Anything else? This is the difference between differential equations and linear algebra. In linear algebra, we would prove that it actually worked. Here, we just said we're going to take a guess and hope that things turn out. So it's the difference between a 200 and a 300 level class. All right, I am done. I will let you go. Be ready for complex numbers on Friday, please and thank you. And don't forget about homework that is due on Friday at 2. Have a lovely day. See you guys on Friday. Bye.